Okay, so we've got to write this function of x in fully factorised form, and standard procedure for this one will be to go down the route of long division, and indeed most mark schemes, when you have a look at them, will use the long division, but I'm going to do it via inspection. We say, well, f of x has got to be, well, if it's in factorised form, it's got to be our linear factor multiplied by some quadratic factor, and there's our generalised version of a quadratic factor. I've just got to figure out what a, b and c are, and the way I'm going to do that is, let's say, okay, let's just have a look at it. Start off with, well, we've got to make x cubed. The only way that's going to happen is if that one there is 1x squared, so a is 1. Given the minus 2 on the end, that means that's going to have to be minus 1. So that's that bit sorted. So all we need to work out now is how many x's we've got. Well, to do that, what I'm going to do is have a look at the number of x squareds. My x squareds are going to come from that bit there and that bit there. So I've got 2x squared from there, which means when I multiply out the other bit, this bit here, the x times x, I need none of them. So what I'm going to do is say, well, I need 0x coming from there. So I'm going to make that 0 x's. Now, what I'd like to do is just check that that will still work for the x term, which is the bit I haven't used there. This is my kind of my safety mechanism. And that bit is going to come from doing x times minus 1, so minus 1x there. And it's also going to come from doing that times that, so there's 0x's there. And do those red bits, the minus 1x and the 0x give me minus x. Well, yes, they do. So I know I've got that right. So let's just write that out a bit. So we've got x plus 2. Write that a bit neater. We'll see what's going on. I've got x squared minus 1. And so now I've got x plus 2, x plus 1, x minus 1, and there it is in fully factorised form.